This is the video for lesson 2.4, solving equations with variables on both sides. The variable terms must be on the same side of the equal sign. Remember, to move a term to the other side, you must perform the inverse operation. The inverse operation. Remember the inverses, so plus and minus are inverses, and multiplication and division are inverses. All right, so the first example says 7k equals 4k plus 15. And draw it down here. So the variable terms must be on the same side, and right now they're not. Right now I have a k here and a k here. It's important to note that it's the same variable. We're only solving equations right now with one variable. So now it doesn't matter if the variable ends up on the left or the right. I don't really care. But you want to kind of think about what this is going to look like based on what you do. So either I need to move this 7k over here, or I need to move this 4k over here. Now, if I move the 7k over here, that means I'm going to have nothing over here. And that's not going to create a problem, but it's going to create an extra step. So instead, I'm going to move my 4k left. If I'm crossing this line, okay, I'm going across the equal sign, I have to make sure I do the inverse. So this is positive 4k. So to move it, I'm going to do minus 4k. Notice that I'm moving the entire term. I'm not splitting up the 4 and the k. Do the same thing over here. And we have like terms. So these are like terms, so I can combine them. 7 minus 4 is 3k equals 4 minus 4 is 0k, so that's gone. Bring down my 15, it's positive. That's a 5. Now I just solve for k like we've been doing. So this is multiplication, 3 times k. So divide by 3, x equals 5. Again, that's a 5. And that's not right. Technical difficulties. Boom. Okay. X equals 5. So we're not really doing anything different, except that now we have variables on both sides, and before we can simplify and solve, we have to make them on the same side. So the next example is 5x minus 2 equals 3x plus 4. All right, so same thing goes. We have to have our x's on the same side. So I have an x term here and an x term here. They need to be on the same side. So I'm going to get rid of this 3x. I'm going to move it to the other side. So in order to do that, I need to take it away because this 3x is positive. So I'm going to take away 3x from this side. And what I do on one side, I must do the other. So I'm going to take away 3x from this side. 5x minus 3x, again, these are like terms, is 2x. My minus 2 did not change, so that comes down. Equals 3x minus 3x is 0, so that's gone. My 4 comes down. Now it's a two-step problem. Plus 2, because my variable is over here, so I want to isolate this. So that's why I'm adding 2. This is 0, so bring down my 2x equals 6. So x equals 3. Why? Because 6 divided by 2 is 3. Remember, we can plug this back in, so I can plug in a 3 here. 5 times 3 is 15, minus 2 is 13. 3 times 3 is 9, plus 4 is 13, so it works. 13 equals 13. Okay, so I want you to do these two examples on your own, and I'm going to be checking those when you come back to class. So based on what I just explained to you, I want you to do these two examples on your own. So now I'm going to move to simplifying each side before solving. So for this example, it says 2 times y plus x equals 3y. So you notice there's a distributive property here. So I need to distribute that before I can move any y terms anywhere. So when I distribute, I get 2y plus 12, because 2 times 6 is 12, equals 3y. Now I can move the y terms. Now, look at this one. I have a 2y here and a 3y here. If I subtract 3y over here, then I'm going to be left with nothing. And again, that wouldn't necessarily be wrong, but it's just going to add an extra step. So instead, I'm going to actually move this over here. So I'm going to subtract 2y. Again, that's a positive 2y. I need to take it away. I'm not splitting up the 2 and the y. Just moving the entire term. 2y minus 2y is 0. Bring down my 12. 12 equals, these are like terms, 3 minus 2 is 1y, or just y. So that's your answer. Y equals 12. Y equals 12. So in this example, you need to distribute this first and then simplify. Well, sorry. You need to distribute this first and then you can move your variable terms to the same side and then you can solve. Down here, notice on the left side, there's no multiplication, but there are some like terms here. That negative 5b and that 2b, they need to be combined first. Then you need to multiply this, and then you can move your b's to the same side. So go ahead and do those examples also on your own before coming back to class, please. All right, last part of this video. An identity is an equation that is always true, no matter what value is substituted for the variable. Okay, that's what an identity is. You need to know that word. The solutions of an identity are all real numbers. And I'm going to show you what that looks like in a second. Some equations are always false. So identity is always true, and then some, we don't have a special name for that, but some equations are always false. And those equations have no solution. So normally, we have an equation that has an answer, right? Y equals 12. So in this equation, y always is 12. But in some cases, an identity, that means that y in some equation could be anything. Then there's also some equations where there's no possibilities for the variable. Okay, so let's look at these. So example, 4h minus 10 equals 2 times 2h minus 5. So I'm going to do that over here. So 4h minus 10, I can't simplify anything there. There's no like terms, there's no distributing, but on the right side there is. So this becomes 4h minus 10. That's an h. Okay. So you should already notice that this is an identity. Why? Because this matches this. But let me show you what happens when I actually solve it. So if I want to get the variable on the same side, I would do minus 4h and minus 4h. Notice that I'm lining this up with the like term. There's a reason I didn't put the 4h right here, because it doesn't go with the 10. 4h minus 4h is 0. 4h minus 4h is 0. So what do I have? Negative 10 equals negative 10, which is a true statement. So you see that the variables were canceled. I have no variables left, and I just have a number equals a number. If those numbers match, then that is all real numbers. All real numbers. That's called an identity. The second one here, as you might guess, is one where it's always false. So let's look at that. Okay, that's my... All right, so we need to simplify the left side first. So this becomes negative 2x minus 4 because negative 2 times 2 is negative 4 equals negative 2x plus 1. So again, you should notice something here. You've got negative 2x and negative 2x, but then you got minus 4 and plus 1. Whereas in the previous example, everything matched. Here, only part of it matches. So let's see what happens when we solve. If I add 2x, so notice I'm adding here because that's a negative 2x. So in order to make it 0, I need to add. So in order to make it 0, I need to add. Do the same thing over here. Remember to line it up with its like term. Negative 2x plus 2x is 0. Bring down my negative 4. Negative 2x plus negative 2x plus 2x is also 0. Bring down my 1. Negative 4 does not equal 1. So this is false. As a false statement, which means the answer is no solution. Whereas this answer was all real numbers. So if it's a true statement and the variable has disappeared, then it's all real numbers. If it's a false statement and the variable's gone, then it's no solution. Okay, so make sure you do these example problems because I'll be checking those in class. And then we'll work some more practice problems. Good luck and thanks for watching.